GitLab is an open DevOps platform. You can use the SaaS version where there is no technical setup required, or you can download, install and maintain your own GitLab self-managed, on your own infrastructure or in the public cloud environment. See the key differences between GitLab SaaS and self-managed. In this blog post we will choose the GitLab self-managed version and deploy the instance using the official Helm chart. This chart is the recommended and supported method to install GitLab on a cloud-native environment. The GitLab/GitLab chart is the best way to operate GitLab on Kubernetes. This chart contains all the required components to get started, and can scale to large deployments. By default, the Helm chart deploys all components on Kubernetes. In a cloud-native environment, to be production-ready, we need to use cloud-provided solution to outsource the dependencies. PostgreSQL on Amazon RDS. Redis on Amazon Elasticsearch. Object storages with Amazon S3. Use an external volume for GitLab. Prerequisites: installing and configuring AWS CLI Terraform kubectl Helm CLI. Create a public hosted zone in Route 53. See tutorial. Request a public certificate with AWS Certificate Manager. See tutorial. Network. In this section, we create a VPC, 2 private and public subnets, 2 NAT gateways and an internet gateway. Following files can be downloaded from the description: plan/vpc.tf, plan/subnet.tf. Following files can be downloaded from the description: plan/nat.tf, plan/igwa.tf. Amazon EKS. In this section we create our Kubernetes cluster with the following settings. Restrict access to a specific IP, it could be your office range IPs, and to the NAT gateways IPs, to use GitLab runners, enable all logs, enable IAM roles for service account security groups for the cluster. Following files can be downloaded from the description: plan/xcluster.tf. Here we create 2 node groups, 1 private and 1 public. Following file can be downloaded from the description: plan/xnodegroup.tf. GitLab. Let's start by outsourcing object storages. External object storage. GitLab relies on object storage for highly available persistent data in Kubernetes. For production quality deployments, GitLab recommends using a hosted object storage like Amazon S3. 1. In the following Terraform we outsource: Docker registry images, long file storage, artifacts, uploads, packages, external pseudonymizer, backups. Following file can be downloaded from the description: plan/s3.tf. We use server-side encryption with Amazon S3 Managed Keys, SSE S3. You can easily replace this encryption by server-side encryption with customer master keys, CMKs, stored in AWS Key Management Service, SSE KMS, 2. IAM permissions. To authorize GitLab to access the object storages, we need to create an IAM role. Following file can be downloaded from the description: plan/yam.tf. External PostgreSQL database. PostgreSQL persists the GitLab database data. We create the RDS instance with 2 read replicas to load balance the traffic. We restrict incoming network traffic only from private subnets. Following file can be downloaded from the description: plan/rds.tf. External Redis. Redis persists GitLab job data. We use Amazon Elasticsearch to create the Redis cluster. Only EKS worker node groups are authorized to access the Redis nodes. Following file can be downloaded from the description: plan/elasticsearch.tf. External persistent volume. GitLab persists the Git repositories and requires persistent storage, configured through persistent volumes that specify which disks the cluster has access to. GitLab currently recommends using manual provisioning of persistent volumes. Amazon EKS clusters default to spanning multiple zones. Following file can be downloaded from the description. plan/ebs.tf. Also here, you can encrypt the EBS resource with Amazon KMS. 4. We have completed creating the necessary AWS resources for GitLab. We are now starting to create the Kubernetes resources. Kubernetes resources. In this section we create GitLab namespace, AWS Access Service account needed to access the S3 object storages, GitLab Postgres secret to store the DB password, S3 storage credentials and S3 registry storage credentials secrets to access the S3 object storages, shell secret for GitLab shell, the storage class, persistent volume and the persistent volume claim used by Gitly. plan/k8s.tf. Helm. We finish by configuring the Helm chart. Following file can be downloaded from the description. plan/gitlab.tf. Deployment. We've finished creating our Terraform files. Let's get ready for deployment. Following files can be downloaded from the description. plan/main.tf, plan/output.tf. Following files can be downloaded from the description. plan/variables.tf, plan/backend.tf, plan/versions.tf, plan/provider.tf, plan/terraform.vars. Initialize AWS DevOps infrastructure. The states will be saved in AWS. Complete plan/terraform.vars and run. 1. Access the EKS cluster using 2. To deploy the Amazon EBS CSI driver, run one of the following commands based on your AWS region. 3. Annotate the EBS-CHI controller Kubernetes service account with the ARN of the IAM role that you created in Terraform. 4. Delete the driver pods. 5. Check if all resources have been created properly. Connect to the GitLab web application with the root user and the initial root password. That's it. The source code is available on GitLab. Conclusion. We discovered in this article how to configure and deploy a production-ready GitLab on Amazon EKS. Hope you enjoyed reading this blog post. If you have any questions or feedback, please feel free to leave a comment. Thanks for reading.